Welcome back to a new machine learning tutorial. In this tutorial, we are going to be talking about standard scalar. We are going to be talking about the idea behind it and how it works. Then we are going to be coding it in Python using Scikit-learn. Let's start coding. So I'm in VS Code right now. I'm going to be using this code editor in this tutorial, but you can use any code editor that you want. You can use Spider, Google Colab, or PyCharm. It's up to you. What I'm going to do is I'm going to open my Explorer. I'm going to close the welcome page. And I'm going to create a Jupyter notebook. Like it's going to be, let's say, standard scalar.ipynb. And then what I'm going to do is I'm going to select the kernel, Python environments 3.11.4. And now we can talk about the feature scaling. So it's going to be feature scaling, and we will say standardization. This is going to be our topic today. So in the upcoming videos, I will be also talking about normalization. So, feature scaling is a technique used to standardize the range of independent variables of features of data. The standard scalar specifically rescales the data so that it has a mean of 0 and a standard deviation of 1. So this ensures that each feature contributes equally to the model's performance and helps algorithms that rely on distances between data points like k and n perform better. So in k and n, we look for the distances between the features, and it's important to have meaningful distances between them. So we are going to use scaling. Let's start with its mathematical formula. So I'm going to create a markdown here, and we are going to say for the formula z, the scaled value, also it's called as z-score, is going to be value minus mean divided by standard deviation. This is going to be our formula for calculating z-score. So this formula ensures that the transformed feature has a mean of 0 and a standard deviation of 1. Okay, so now let's apply this formula using Python but without libraries. So what we are going to do is I'm going to create example values like data, and let's say like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And next, what I'm going to do is we need to calculate the mean firstly, because in our formula we have the mean. So let's do that. For calculating the mean, I will say mean, and this is going to be equal to the sum, and I will give data, and I'm going to divide it by the length of the data. So our mean is going to be 5.5. And now what I'm going to do is I'm going to calculate the variance for finding the standard deviation. So for the variance side, what we are going to do is I will say sum. I'm going to open two parentheses. I will say x minus mean, and we will take the power of 2 like this for x in data. And then we are going to divide it with length of the data. And this is going to be our variance. And for reaching the standard deviation, what we are going to do is we will say standard deviation, and it's going to be equal to the square root of the variance. Like this. We are going to apply this, and we can check standard deviation. Here is our standard deviation value. So we have both the mean and standard deviation right now. And for finding the scaled data, what we are going to do is we are going to apply the standardization formula to each value in the feature using the mean and standard deviation we calculated earlier. So let's do that. It's going to be scaled data, and we will say x minus mean divided by standard deviation for x in data. And let's see our formula, x minus mean divided by standard deviation. So it's basically the same thing, and I will call scaled data right now, and we are going to have our scaled data. So now the scaled data contain values with a mean of 0 and a standard deviation of 1. How we can check that is we can just call numpy, and then we can say scaled data. Actually, I will firstly call a numpy method, like let's import it as mp, and then I will say numpy.mean, and I will give scaled data in here, and we are going to get, let's check it quickly. So I will import numpy as mp, Then I will say round. I don't want any type of decimals because in scientific numbers there can be really small decimals. I don't want that. We will say numpy.mean and we will pass the scale data in here. And our mean is 0 in our scale data as we talked. And let's also check the standard deviation on scale data. We are going to have 1. Great. But we don't need to use this method every time because it can be time consuming if you have a lot of features or stuff like that. Like you can do this easily using Python's library, and we are going to use Scikit-learn, which is a great library for machine learning. So let's apply that using a Python's library. So we will say from Scikit-learn that preprocessing import standard scalar. And now what we are going to do is let's create our data in two-dimensional format. Like I will say data numpy array. I'm preparing in this way because most of the machine learning models want the data in this format, so it's going to be more like a real life case. I will say 3. I'm not going to give a lot of numbers in here. I will stop at 7, so 6 and 7 like this, and we have our data ready right now. So at the first place what we are going to do is we are going to initialize the standard scalar that we imported in here. So what I'm going to do is I will call the scalar and it's going to be standard scalar like this, and then we are going to fit the scalar to the data. So this is going to calculate the mean and the variance, and also for sure the standard deviation. So I will fit it, and you can see the small thing appeared on the screen. And the final step is going to be transforming the data. Like scale data is going to be equal to the scalar that transform data. And now we can call scale data like this. And we are going to have our scale data like that. And let's just test this data, like numpy.mean scale data. Also I want to use round again like this, and it has the mean of the 0. And let's check the standard deviation side of things. Scale data, we have the standard deviation of 1. So I will call the data again, because you can use these two methods together. Like you can say scale data new, and it's going to be a scalar. We can use fit and transform together, like fit transform. And when we use like that, we are going to have our scalar calculate the mean and standard deviation firstly and then transform it. So let's make this run and check scale data new, and it's similar like with the one in here. Great. So this is how we can apply scaling using standard scalar from Scikit-learn. And let's also do an example for multivariate data. Like let's create something like data is going to be numpy array, and we will say like two-dimensional 1, 2. This time we are going to give it like this with multiple features like 3 and 4 and 5 and 6 like this. And how we can scale this is, let's say scale data multivariate, and it's going to be scalar fit transform. The same method we will give the data. So when we call the scale data multivariate, we are going to have this. So each feature in scale data will have a mean of 0 and a standard deviation of 1. Like what I mean by feature is column. Like this is a column and this is a column. And by here you can see that we have the minus same value with the positive same value, which means that their mean is 0. So let's summarize what we did in the video, then we can finish this coding tutorial. So we started with defining the mathematical formula, then we applied the formula without using any kind of libraries. We calculated the mean by taking the sum of the data and dividing it by the length of the data. Then we calculated the variance in here, and we find the standard deviation by taking the square root of the variance. Then we applied our formula in here, x minus mean divided by standard deviation, and then I showed you the mean and standard deviation 0 and 1, and then we imported the standard scalar and we tried that on our data in here And we see that we get the standard deviation and mean values that we want, and also we apply the same thing in a multivariate data. And this was all. Thanks for watching this machine learning tutorial. I have a playlist for machine learning videos where I have more than 40 videos. You can check that playlist from the cards of this video. Also, I'm sharing a new data science video every week on my channel. You can subscribe to my channel for more videos like this. Have a great day.